Hello students and welcome to this video on permutation and combinations. We will solve question number 221 to 230 in this video. And I will say, which I always say in my video, is that when I'm stating the problem, you should pause the video. And only if you cannot solve the problem yourself, you should look at the solution. The second thing is that you should not spend more than 15 minutes on a problem. If you cannot solve in 15 minutes, you can look at the solution or skip the question and move ahead. Come back later when you feel more confident to solve the question. The link to download the PDF will be in description, as well as at the end I will show you how you can download. So without further ado, let's get started. Question 221 says that if A and B are positive integers, show that AB factorial divided by A factorial multiplied by B factorial to the power A is an integer. So this given fraction is number of ways of distributing AB things in A sets, each having B things, which will be an integer. Question 222 says that a conference attended by 200 delegates is held in a hall. The hall has 7 doors, A through G. At each door, an entry book is kept, and delegates entering the door sign it in the order in which they enter. If each delegate is free to enter any time and through any door they like, how many different sets of 7 lists would arise in all? So this is like distributing n identical objects in our groups, where each group can contain any number of objects. And the ordering matters, and that is equal to n plus r minus 1 pr. So this is equal to 206 p6. Or rather, this should be 7 actually. R is 7. Question 223 says that in how many ways 16 identical objects can be distributed among 4 persons if each person gets at least 3 objects. So method 1 is, since each person has to get at least 3 things, if 3 persons get 3 things, 4th can get at most 7 things. So we have 16 objects, so 3 3 to 9 plus 7 16. So the required number will be coefficient of x to the power 16 and x to the power 3 plus x to the power 4 through x to the power 7 whole to the power 4. So we take x cube common, that is coefficient of x to the power 16 and x to the power 12, multiplied by 1 plus x plus 2 x to the power 4 to the power 4. So this is coefficient of, this should be x to the power 16 and x to the power 12. So we subtract and we get coefficient of x to the power 4 in 1 minus x to the power 5 by 1 minus x whole to the power 4, which is equal to 7c4 or 35. Now, second method is, let the 4 persons be given A, B, C, D number of things, then A, B, C, D is 16, where A, B, C, D are all greater than or equal to 3. Then W plus X plus Y plus Z is equal to 4, W, X, Y, Z is greater than or equal to 0, and W is equal to A minus 3, X is equal to B minus 3, Y is equal to C minus 3, and Z is equal to D minus 3. So required number of solution of any of the above equation, which is the number of ways of distributing 4 identical things among 4 persons, where each person gets any number of things, is n plus r minus 1 CR. So our n is what? R is 4 and n is also 4 here. So because we have 4 persons. So that is 7c4 and the result is 35. The third method is, set of 4 positive integers which greater than or equal to 3 whose sum is 16 are 7, 3, 3, 3 and 6, 4, 3, 3, 5, 5, 3, 3, 5, 4, 4, 3 and 4, 4, 4, 4. Elements of first set can be arranged in 4 factorial by 3 factorial ways. Elements of second set can be arranged in 4 factorial by 2 factorial ways, and so on, and eventually when we add them, total is 35. Question 224 says that, show that a selection of 10 balls can be made from an unlimited number of red, white, This is white, blue and green balls in 286 ways, and that 84 of these contain balls of 4 colors. So number of red, white, blue, and green balls be W, X, Y, Z respectively. Then W plus X plus Y, Z is equal to 10, where W, X, Y, Z are greater than 10. So this is number of ways of distributing 10 identical things among 4 persons, where each can get any number of things. N is 10, R is 4, so it is 13C10, which is 286. This 10 needs to be sectioned. When the selection contains balls of each color, the equation remains same, but W, X, Y, Z greater than equal to 1. So A, B, C, D will be equal to 6, where A is equal to W minus 1, B is equal to X minus 1, C is equal to Y minus 1, and D is equal to Z minus 1. So here N would become 6, R would become 6, and N would be 4. So the answer is 9C6, that is 84. Question 225 says that in how many ways 30 marks can be allotted to 8 questions if each question carries at least 2 marks. So we let the marks contain x1 through x8. Then from the question, x1 plus x2 would be equal to 30. Now this is x1, not x minus 1. So x1 through x8 would be greater than equal to 2. Now y1, y2 through y8 is equal to 14, where y1 is equal to x1 minus 2, y2 is equal to x2 minus 2, and so on. The required number of solutions in this case, n would be 8 and r would be 14. R would be 14 and n would be R would be 8 and n would be 14. So the total number of ways is 21C4, that is 116,280. Question 226 says that in an examination, the maximum marks for each of the 3 papers is 50 each. Minimum marks for the 4th paper is 100. Find the number of ways in which a student can score 60% marks in aggregate. So we have total marks of 3 multiplied by 50 plus 100, that is 250. To score 60%, a student needs 150 marks. So required number is coefficient of x to the power 150 in 1 plus x plus through x50, where the powers of x represent marks. So the student can score 0 to 50 in 3 papers. That is why we have cubed this. And in the 4th paper, a student can score from 0 to 100 marks. So this is coefficient of x to the power 50 in 1 minus x to the power 15 by 1 minus x cubed, multiplied by 1 minus x to the power 100 by 1 minus x, which is equal to 1 minus x to the power 51 minus to the power cube into 1 minus x to the power 101, multiplied by 1 minus x to the power minus 4. So that is coefficient of x to the power 150 in 1 minus 3x to the power 51 plus 3x to the power 102 minus x to the power 101. We ignore the powers greater than 150. This should be 150. And then multiplied by 1 minus x to the power minus 4. And then we expand that and we have the result as 153 C50, 3 into 102, 90, 3 dot C51, 48, and minus 52 C49, and total is 110,555. Question 227 says that let n and k be positive integers such that n is greater than or equal to k into k plus 1 by 2. Find the number of solutions x1, x2 through xk such that x1 greater than 1, x2 greater than 2, and xk greater than or equal to k, all satisfying x1 plus x2 through xk is equal to n. So we let y1 is equal to x1 minus 1, y2 is equal to x2 minus 2, yk is equal to xk minus k. So sum of y1 through yk would be n, where n is x1 through xk added. So n minus 1 plus 2 through k, that is n minus k into k plus 1 by 2. Now we are given that n is greater than this. Okay, so this is equal to m. So we let this is equal to m. So number of solutions would be m plus k minus 1 cm. So this is your required number of solutions, which you can simplify. Question 228 says that find the number of integral solutions of equation x plus y plus z plus w is equal to 29, where x is greater than 0, y is greater than 1, z is greater than 2, and w is greater than equal to 0. So you have to take care of the fact that some are greater than and some are equal to. So we write x plus y plus z plus w is equal to 29, that is given. And x would be greater than equal to 1. It is greater than 0, so greater than equal to 1. Y would be greater than equal to 2, and z, z would be greater than equal to 3. Z is nothing here. We substitute p is equal to x minus 1, q is equal to y minus 2, z is equal to y minus 3. So p plus q plus r plus w would be 23, where p, q, r, w greater than equal to 0. So now we know that. So the total sum would be 26c 23, because 23 plus 24, these are four different variables. So 23 plus 24 minus 1, c 23, that is 2600. Question 229 says that find the equation of non-negative integral solutions of the equation x plus y plus z plus 4w equal to 20. So the required number would be quotient of x to the power 20 in 1 minus x to the power minus 3 multiplied by 1 minus x to the power 4 minus 1. So you see, the quotient of x, y, z would be the power of x here. So it is 4w, that is why it is x to the power 4. And these are 3, so we have got cube, and w is 1, so we have got minus 1. Now this is equal to quotient of x power 20 in 1 plus 3c1x plus 4c2x square, and so on through c22, c20, x to the power 20. We don't consider terms after x to the power 20 here. Similarly, we expand the second one till x to the power 20, and we multiply and take quotients whose other factor, that is powers of x, is less than 20, and we get 1 plus 6c4 plus 10c8 plus 14c12 plus 18c16 plus 22c20, that is 36. Question 230 says that find the number of non-negative integral solutions to the system of equations x plus y plus z plus w plus v is equal to 20, and x plus y plus z is equal to 5. So we are given that v plus w and x plus yz would be 3. And now there is some mistake. So v plus w will become 15. Okay, that is correct. How come x plus y plus z is 3? Okay, let me think. So v plus w will be 15. We put it here, then it becomes 15. No, this should be 5. This is 5, guaranteed to be 5. It is a typing mistake. So number of non-negative integral solutions of these equations combined would be 7c5 and 16c15. So yeah, this is definitely 5, this is not 3. This is 5 plus 3, that is number of people or number of variables. 5, 3, 8 minus 1, 7, c5. And then this is 15 plus 2, 17 minus 1, 16. And then c15, that is 336. So to understand most of the problems in this set, you need to read this section, okay? Integral solution of equations, or how do you distribute things. Okay, the other section which you can read is combination with repetition and permutation with repetition. Okay, so these sections, if you read, you will be clear how to solve the problems. Now I will show you how you can download the book. You can go to my website astabako.org, and second, third, and fourth link contain algebra, trigonometry, and geometry book respectively. Conic sections of coordinate geometry is being written, and as soon as that is complete, I will add that here. So the link in YouTube will not include coordinate geometry book. I will add it once it is complete. So don't wait for the video. Go ahead and solve the problems given in the PDF. And if you have any confusion, you can ask me questions in the comment box. And if you have any problems from any 12th book, you can go ahead and ask me in the comment box. I will try my best to answer that. So I hope that you are finding these videos useful. And if you have not watched the earlier videos, you can go ahead and watch the entire playlist. So I thank you for watching the video, and we will meet again tomorrow at the same time with 10 more problems and permutation combination. So till then, keep practicing and enjoy.